Math Singer, yum!
Constructing linear functions is a necessary skill in many areas of mathematics, particularly in algebra and calculus. Students are often taught to memorize various forms of the equation of a line and then decide which one best applies to a given problem. However, none of these forms of a linear equation are really necessary in order to construct functions that describe a linear relationship between two variables. It turns out that every linear function can be constructed using three simple steps. We're going to demonstrate these steps in this video with two examples from algebra and one from calculus. Consider the problem of constructing the function f that describes the line passing through the points -2, 1 and 3, 4. Step 1.
Graph it.
Sketching a graph of the line that you're working with allows you to make friends with the problem at hand. In a very real way, the graph actually is a solution to the problem, a visual solution that will allow you to verify the algebraic solution that you will obtain later on in your work. You should include in your graph all of the pertinent information that is presented in the problem. In this case, you should include the points -2, 1, and 3, 4, as well as a sketch of the line that passes through these 2 points. You should also include a third point on the line, a generic point that is labeled with the names of the independent and dependent variables that you are using in your work. In this example, we will label our generic point as xy. We're now ready to move on to step 2.
Slope it.
The only equation that you really need to remember when constructing a linear function is an equation that you really simply cannot forget. That equation is slope equals slope. It turns out that every linear equation is just an expression of the fact that the slope of a line is the same regardless of the points of the line that are used to express it. In this example, we can calculate the slope, the difference in y values over the difference in x values, using the points 3, 4 and -2, 1 to get 4 minus 1 divided by 3 minus -2. But we can also express the slope of the line by using the points x, y, and 3, 4 to obtain the expression y minus 4 divided by x minus 3. Because the slope of a line is the same regardless of the points of the line that are used to express it, these two expressions are equal to each other. That is, slope equals slope. And because one of the expressions that we used for slope used the generic point xy, this result actually turns out to be an equation. In fact, what we have developed really is an equation of the line that we're looking for. However, the form of this equation does not explicitly provide the function that we are seeking. This brings us to step 3.
Solve it.
All that's left to do is to solve our equation for the dependent variable y. We'll begin by writing the right side of our equation as 3/5 and then multiplying both sides of the equation by x minus 3. This gives what is traditionally called the point-slope form of the equation of the line. Multiplying 3/5 by x minus 3 gives 3/5 x minus 9/5. And finally, adding 4 to both sides in the form of 20/5 yields that y is equal to 3/5 x plus 11/5. This is generally known as the slope-intercept form of the equation of the line, since it explicitly provides us with the slope of the line as well as with the y-intercept of the line. It is also the form that explicitly tells us how to calculate the y value, the output of our function, from a given input value of x. Therefore, it tells us that the function f that we were asked to find is described by f of x equals 3/5 x plus 11/5. Let's look at our three-step process for constructing linear functions with another algebraic example. We know that water freezes at 32 degrees Fahrenheit and at 0 degrees Celsius. We also know that water boils at 212 degrees Fahrenheit and at 100 degrees Celsius. Use these facts to construct the linear function that outputs degrees Fahrenheit given degrees Celsius. Again, we begin with step 1. Graph it. We'll start with a pair of coordinate axes labeled C and F for Celsius and Fahrenheit. We'll plot 2 points, one indicating the freezing temperatures of water in Celsius and Fahrenheit, and one indicating the boiling temperatures of water in degrees Celsius and Fahrenheit. Then we'll draw the visual solution to our problem and include a generic point on this line. This brings us to step 2. Slope it. Again, the only equation that you need to remember when constructing linear functions is that slope equals slope. Using the points CF and 0, 32, we can express the slope of our line as f minus 32 divided by c minus 0. We can also express the slope of our line using the points 100, 212, and 0, 32. And since slope equals slope, we have that these two expressions are equal to one another. And we can now move on to step 3. Solve it. Simplifying the left and right-hand sides of our equation gives us that f minus 32 divided by c is equal to 180 over 100, which is equal to 9/5. Multiplying both sides by c gives that f minus 32 is equal to 9/5 c. We then add 32 to both sides to see that f is equal to 9/5 c plus 32. We can then express our answer in functional notation by stating that f of c is equal to 9/5 c plus 32. Our last example is a typical question from calculus. Find the equation of the line that is tangent to the graph of f of x equals 6x minus x squared minus x cubed at the point on the graph at which x is equal to 1/2. Graph it. We begin by drawing a sketch of our function f and a line tangent to the graph of f at the point where x equals 1/2. The y-coordinate of this point can be expressed as f of 1/2. Evaluating f of 1/2 shows that the y-coordinate of our point of tangency is equal to 21/8. We will also draw a generic point, x, y, on our tangent line. We're now ready for step 2. Slope it. As before, we now need to express the slope of our tangent line in 2 different ways. Once using our generic point xy, and then again using a numerical expression. Using the fact that xy and 1/2 21/8 are both points of our tangent line, we can express the slope of this line as y minus 21/8 divided by x minus 1/2. However, we do not have the explicit coordinates of another point on our line like we did in the previous 2 examples. Nonetheless, we do know that the slope of the line that is tangent to the graph of x equals 1/2 is equal to the derivative of our function at 1/2. Since the derivative of f is equal to 6 minus 2x minus 3x squared, we can calculate f prime of 1/2 to be equal to 6 minus 2 times 1/2 minus 3 times 1/2 squared, which is equal to 17/4. This supplies the right-hand side of our slope equals slope equation. At this point, we are ready for step 3. Solve it. Multiplying both sides of our equation by x minus 1/2, distributing, and then adding 21/8 to both sides of the equation gives that y is equal to 17/4 times x minus 17/8 plus 21/8. Therefore, we have that the equation of the line tangent to the graph of f at the point where x equals 1/2 is y equals 17/4 x plus 1/2. I've recorded a short tune to remind you of this three-step process that can be used to construct the equation of any line. Please enjoy listening to it while you consider liking this video and subscribing to this channel. I'll see you in the next video.
Rapid, slope it, solve it. 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 Rapid, slope it, solve it.